Meta released Muse Glimmer on August 10th, a 30 billion parameter open model built to run on a single consumer graphics card instead of a data center. That's a genuine first for the classification and extraction work a lot of SEO and data pipeline jobs actually run. I do want to say up front that I never ran this model myself, or DeepSeek's either. Everything in this video comes from published pricing and hardware specs, plus my own check of OpenAI's current rates, so treat the arithmetic as the finding and not necessarily a hands on test. But three things happened inside 12 days, and the order matters. On July 30th, OpenAI cut GPT 5.6 Luna's price 80%. A day later, DeepSeek put a 304 billion parameter open model on Hugging Face. And then 10 days after that, Meta shipped Muse Glimmer. So the API got radically cheaper before a genuinely local capable model even arrived. That ordering is basically the whole reason I made this, because it flips what you would expect the timeline to do to the math. At full precision, Muse Glimmer's 30 billion parameters would need more than 55 gigabytes, which is more than any consumer card I know of carries. Meta compressed the weights to roughly 4-bit precision, and that shrank the model to under 20 gigabytes. But that leaves room in a 32 gigabyte card for working memory and an image module too. Meta tested it on an RTX 590, a $1,999 graphics card, and on a MacBook with an M4 Max or M5 Max chip. DeepSeek shipped something genuinely open to a 304 billion parameter model under an MIT license, all its weight public on Hugging Face, and that openness is real. But open weight and locally runnable turned out to be two different claims. DeepSeek's own model card, which you are looking at right now, gives a serving example on a single 4 times GB300 node, 4 NVIDIA accelerators in one server, sized and priced for a data center and not a desk. This is the number that actually moved. Let's say you take a representative call, 500 tokens in, 100 tokens out, roughly what a product title classification task would look like. Before OpenAI's cut, that call costs about a tenth of a cent, and a $2,000 GPU would pay for itself around 1.8 million calls. After the cut, the same call costs about a fifth of that again, and the same GPU does not pay for itself until about 9.1 million calls. Local models get no faster or cheaper to run in that meantime. Only the price of not buying one has changed. I wanted a receipt for that number, so this is OpenAI's own live pricing page, which I checked the same day this video runs. Luna prices at 20 cents per million input tokens and $1.20 per million output tokens. That's exactly 1/5 of its dollar and $6 launch prices on both sides, input and output. So 5 times cheaper, which is where the 9.1 million figure comes from. An earlier piece on this channel argued that past a few hundred identical items, calling an API directly beats spawning a subagent per item, and it named the context window filling up as the reason and never the price. I do want to be careful here because recomputing that comparison at today's rates does not update it into a new number. I checked and it does not. A GPU is a fixed cost, so the more volume you run through it, the cheaper each call gets. That's exactly why OpenAI's price cut could move the break even at all. The subagent comparison has basically no fixed cost on either side. If delegating costs more per item, it costs more at every volume rather than past some threshold, so there's never a crossover for me to find. Local losses, or loses rather, outright on a few things regardless of price, so long context work, the hardest reasoning tasks, and anything that needs a guaranteed output shape. This next line is my own read, not something Meta claims about Glimmer. A misclassified product title from a broken local JSON parse costs more than the tokens you saved by skipping the API call, because a hosted API built around strict schema validation is just a more reliable way to guarantee a parsable result. And to be fair to local, I think it still wins outright when the hardware is already paid for, when the data cannot leave your machine, or when there is no connection to call an API at all. So this is how you would find your own number. Multiply your average tokens per item by Luna's current rates, add input and output together, then divide the price of the hardware you would buy by that per item cost. That formula skips 4 real costs though. Electricity, since this card draws up to 575 watts under load. There's depreciation because a GPU bought today will not be worth the same in 2 years, and your own setup and maintenance time. The sharpest one is basically the assumption that both prices, what the API charges and what you paid for the card, hold still for as long as reaching the break even takes. My own news peg here is 2 price moves in 12 days. So put it together, and paying per token still wins for most realistic SEO and pipeline volumes, and by a wider margin than it did just 3 weeks ago. None of this makes Muse Glimmer or DeepSeek less real. A genuinely capable, locally runnable model on consumer hardware did not exist 3 weeks ago, and now one does. The full arithmetic, every figure, and the four costs the formula leaves out are all on my website. But I would like to know where your own realistic monthly volume sits against 9.1 million calls.